Alright, I hope everybody's doing okay. Today, what I really want to talk about is distribution. And we want to understand what is distribution really. Now, in a sense, it is a depiction, a visualization, or a description of how possible values are distributed in the dataset. And in, in all simplicity, it is essentially the likelihood of occurrence of those possible values in the dataset. Consider the example that I have here in front of me, which is a dice score. So I've rolled a dice, a six-sided dice, and it could take any of the six values, right? It could take 1, 2, 3, 4, 5, and 6. And I've rolled the dice, I've recorded the outcome, and I've done this many times. I hold the shift key and go all the way to the bottom with my command key, and I could see how many of these values there are, and it selects the entire data set. I have 120 dice rolls recorded here with me, right? So how do I visualize this as a distribution? How is this data distributed? How many times have I had one shown up, or two shown up, or three, four, five, and six shown up? So that would essentially constitute a distribution of my data set. Now, since this is a fair dice, I would expect each of the faces of the dice to show up equal number of times, right? Because this is a fair dice, so there's an equal chance for all of these faces to show up. And in a distribution such as this, where you have equal chances for all outcomes to, to, to appear, typically refer to that as a uniform distribution. But what I want to do now is show you here on Excel how we could really visualize this. And there are many ways to do it. We are in effect going to look at three ways to do it. Now, I could start with referring to what's called a value, right? And then look for a count for it. Okay, so for example, the values that I would have in this dice would be 1 to 6, right? And one simple way to count for how many times have I had 1 in this data set would be to use the countif formula, which as you could see here is essentially specifying a range, right? And then a criteria. What am I trying to count? So I'm trying to count 1 in this range of data set and how many times that has happened. And that gives me it has happened 15 times, and I could always drag this to ensure that this happens for all of the other values. But just to check, just to ensure if this has actually worked, right? So well, I noticed that it has skipped the first value. But if I go here, it seems to have skipped the first two values in the range. Here, I've skipped a few values. So it's kind of, if I notice my formula in the formula bar, because I dragged it down, it seems to have interpreted that as dragging my range down, and this is not something I was looking for. So what I could do here is I could fix my range by specifying or locking my cells or my range with these dollar signs, right? So if I look at my formula bar, I've essentially inserted these dollar signs between the alphabets and the row numbers, right? And that kind of locks in my range. Now when I drag it, I don't see my range being shifted, so I have my range pretty much fixed, right? So that solves my problem. But for the dice phase 2, I would need to specify the count for 2, right? For 3, I would call this 3. For 4, I would want it to look for 4, for 5, 5, and for 6, 6, right? So that settles my count for each of the values that could possibly occur, right? So that gives me a summary of sorts for my dice scores. Now, what I could do next is I could always go to insert and set up a bar chart, so to speak, right? And when I see this bar chart gives me values and counts, and that's not, and the values are not something that I'm looking for, right? So I could always go ahead and delete them, or the simplest way would have been to just select count as my data. As you can see, these always get highlighted, and this gives me a count of all of these 6 possible values. Now when I could always go into format and look for the format pane, and work with these different options, such as I would probably want to reduce the gap width. That could give me a histogram view of this distribution. A few things that I could perhaps do to make it look slightly better would be to have a solid borderline, and that would make some sort of a visualization in a better way. Yes, there are different chart designs that you could always look at. Now, the point here next is this is just one kind of visualization, which shows that the dice phase 1 has occurred 15 times, 2 has shown up these many times, 32 times, and this is in a sense is a distribution of the outcomes of my dice scores. By no means this is a uniform distribution, which is what I was expecting, because the dice is a fair dice. But this is it is what it is. It is what has happened in 120 dice rolls. Now another way to do a similar thing would be to simply select my data, and I could always select my data and head over to insert and go to histogram, right? And this would give me a histogram distribution, which is essentially the same thing, but it looks different here because of the intervals that have been set up. And I could always click on these bars to get access of these format data series pane. If you're on Windows, you might need to double click the intervals to get access to the pane, right? So for me here on the Mac operating system, I get to click on the bars, and that gives me these bins in this data series, and I could always manipulate these bins, specify a certain bin width. For example, I might want to specify 0.9, because that would then ensure that the first bar is for ones and the second bar has an interval such that it only takes into account the outcome 2, because it is 1.9 to 2.8, and I know that the possible value in this range is just 2, so it's representing 2's. Similarly, this is representing 3's, 4's, 5's, and 6's, right? So that's another way to make sure that you could represent the data or create a distribution visual out of your data set, right? So that, and then there are different options for viewing. A third option that is also super interesting is to go into data and then look for the data analysis on this top right, and there you could find a histogram, and there are a bunch of options for analysis. What we're looking for is a histogram, and once you choose histogram, what you could do next is simply specify the input range of your data, right? So I have my range set up from A2 to A21. If you don't, you could always click the first cell, hold Shift, Command, and all the way down, right? The down arrow key. For Windows, it's Shift, Control, and down arrow key, right? And then click back to this, okay? And then that gives you the range that you have set up. It also, and that's the data range, right? But you also need to specify the bin range. Like, what is the bin range that you would want for your histogram? Remember, the bins are these intervals that you see on the x-axis, right? So I would use this that I have already here. So these are my bins, 1 to 6. I want to see how many times 1 to 6 these values have occurred, right? So these are my bins on the x-axis, and this is what I could specify here. Then the next thing is the output range. Where do you want this to be set up? You could choose any empty cell. I'm going to just choose K2, and then you might want to have the chart output selected. Once you've got these options set in, you could click OK, and what you would see is a bin frequency followed by a histogram for the same. Now, this histogram looks pretty solid, but one of the things we might want to take care of is remove the more option so that we only have the bins from 1 to 6 and their corresponding frequencies. How many times do they occur? Now, all of the three visuals that you've seen have pretty much given us the same outcome, the same results, right? And that is what it is. It's just three different ways to do this. Uh, but then now you know how to, and you could choose whichever way you find uh, better to plot these distributions. What's more important at this point is, yes, you could plot different distributions, but why do we not have these outcomes for uniform height, right? Because you expect 1, 2, 3, 4, 5, 6 to occur at the same number of times, right? But that the condition with that, and refer you to the previous video as well, is if you sample enough, you approach close to the truth or the ground values. You know that the dice is fair and has 6 sides, and those sides should appear equally. But just because we've not sampled enough, it's possible that our distribution looks a bit distorted. So what we're going to do next is head over to Google Colab. We could look at a code where we could simulate these dice rolls. So instead of me having to, and because I roll the dice 120 times, I don't want to do it 1,000 times. So I could always go to a programming language and simulate these dice rolls and plot them. So the first two lines, line number 2 and 3, are simple imports for NumPy and Matplot libraries. Line 6 takes care of these random outcomes that I have, and this gives me a random number between 1 to 6. I have to specify 7. That makes my numbers inclusive from 1 to 6. And then how many dice rolls do I want? So I'm going to start with 10 dice rolls and store all of this in dice rolls variable. And then I'm going to use a unique function from the NumPy library, right? And this unique function is going to be fed with these dice roll counts. It's just the column of outcomes of the dice rolls, but I also specify that return counts should be true. What this enables me to do is it gives me the counts of the unique values in my dice rolls variable. So my dice rolls variable has 1 to 6 dice outcomes, and I get a count of these outcomes too, right? So the unique values are 1 to 6. This is what I expect, because this is what I decided when I set up my random function here. And then we simply plot. We plot the unique values and the counts against the unique values. And this is a fairly simple plot that we look at. So let's just run this code, Control Enter, Command Enter as a shortcut, and let's just look at these dice rolls. And in these 10 rolls, I have a distorted distribution, because it's possible you don't get a 2 and you get other numbers. So what I'm going to do now is change 10 to 100 dice rolls and see what does my distribution looks like. And I get a good representation of all of these outcomes, but again, it's still not uniform enough. So how many dice rolls? If I increased dice rolls to 1000 now, I should expect the graph to head towards a uniform distribution, which is in fact the truth for the dice rolls. And we see that the outcome begins to align with the uniform distribution, where each outcome of the dice roll approximates to be an equal number of times. And let's just increase the dice rolls to 10,000 now and have a look at it. And we see that this in fact approaches a uniform distribution, where you have a uniform value or uniform count for each of these outcomes of the dice. And just for good measure, I'm just going to go to 100,000 and see that yes, in fact, we are heading close to the ground truth of uniformity in outcome for each dice outcome, right? So that is the essence of uniform distribution, and you could simulate these dice rolls in Python, visualize them too, but you realize that with sufficient number of dice rolls, you get closer and closer to what the true distribution of that specific process is.